Hello, everyone. Welcome back. In this video, we will introduce breadth first search. In the previous video, we introduced depth first search and used depth first search to solve problems. And there's another popular search is the breadth first search. Breadth first search the graph. First, you visit a vertex, and then visit all the neighbors, and then visit all the neighbors of the neighbors. So here's the example. Suppose we have this graph right here. We're going to pick 0 to start with. So we're going to search 0. And now we're going to visit all the neighbors of 0. So any of this not in any particular order. So let's say 1, 2, 3. And after this, we're going to visit the neighbors. So this is the only thing left is 4. So that's the breadth first search. The result of the breadth first search is a search tree. The root of the search tree is the starting vertex. And so here's 0, and these are the children of 0, and this is the child for 1. Here's the algorithm to describe a breadth first search. So here we have, this is the graph consisting a set of vertices and edges, and that's the input. And the output is a breadth first search tree rooted at this V. So this is the vertex V. Now we're going to use a queue to store the vertices to be visited. Initially, we create an empty queue for storing vertices. And now we're going to add the V to the queue. Mark V visited. Why the queue is not empty, dequeue a vertex, say U, from the queue. Add U into a list of traversed vertices. For each neighbor W of U, if W has not been visited, we're going to add W into the queue. Set U as the parent for W in the tree. Mark W visited. So this is the algorithm. Let's go back to look at the implementation for a moment. So here's the implementation, and the implementation is in this listing 22.2. So if you look at this, here's the implementation for this breadth first search. And right here, and this is the breadth first search starting from this vertex V. So we have this search orders is empty. So this is the parent, and to denote the parent of a vertex in the search tree. So we use the queue, and the queue is initially is empty queue. And so is visited. So all this initially, it's a list, and for every vertex you have a value, and that's false, means it's not visited. So now we're going to start to add this V into the queue, in queue. Is visited view, V now becomes true. Why not? Queue empty. So queue is not empty. So we dequeue and U and put U to the search order. And now we look at all the vertices adjacent to U. So in this edge, and get the W here. And if this W is not visited, we're going to enqueue W into the queue. And set the parent of W to U. Is visited W, now it becomes true. So all of this, and in this for loop, after this all finished, we visited all the vertices. Finally, we're going to create the search tree starting from this root, and this is the root, it's V, and all the parent and the search order. And so this is all the vertices in the graph. Now this is the test program, and using the breadth first search. So here we have, this is the graph with all the cities and the edges connecting the cities. And we create this graph using the vertices and edges. And this is the breadth first search starting from Chicago. So we need to get index. So this is graph.getIndex Chicago. So now after you get this BFS, you can get all the search orders, and you can find the number of vertices in the search tree. And so this will print all the vertices in the search order. And this is the, and to print the parent of the vertex in the search tree. The application of the breadth first search is very similar to depth first search, but there's some unique things we can do use the breadth first search. Now let's look at all those, the applications. So we use the breadth first search and detect whether a graph is connected. So we know if graph is connected, if there's a path between any two vertices in the graph. So if you search in the search, and if you have these two vertices in the search tree, and so there's a path between the two. Detecting whether there's a path between the two, right? So this is all here, and finding a shortest path between two vertices. So that is very unique to breadth first search. You can find the shortest distance, shortest path between two vertices. So they're connected through how many edges. So this is the shortest path. We can use breadth first search to find a shortest path. Finding all connected components, and you can use the breadth first search to do this. And so if the graph is not connected, you find all the connected components. Detecting whether there's a cycle in the graph, and finding a cycle in the graph, and testing whether a graph is bipartite. A graph is bipartite if the vertices of the graph can be divided into two disjoint sets, such that no edges exist between the vertices in the same set. So this is called a bipartite graph. And you can look at the program exercises and to apply depth first search to solve these problems. That is all for this section on breadth first search. See you on the next video.